In this video, I'm going to show you a couple of text manipulation tools that are really useful. One is called SED. The second one is called TR, stands for translate. Here I'm going to start from the data shell directory. And here I have a file called wells_invisible_man.txt. This file is the complete text of the science fiction novel by Herbert Wells. It was published in 1897. And now it's under public domain. Let's take a look at what we can actually do with this novel. First, let's actually count the number of occurrences of invisible in the novel. I'm going to say grab invisible file name, and that returns a lot of matches. Let's count them by passing this with a pipe to wc-l, line counting command, and we see that we have 60 matches. Let's count uppercase I invisible, and we have 114 matches. Let's now count -I invisible, so that is case insensitive search, and we have 176 matches. Now notice that this number is smaller than the sum of these two, and this is because we also have a few instances of all uppercase invisible letters. Okay, now let's run our SED command. We're going to convert every occurrence of invisible to supervisible. Instead of quotes, I will have special syntax that is unique to SED command. I'm going to say S stands for search, then search for invisible, and then every instance of invisible is going to be converted into supervisible. And now also we'll do the same for both uppercase and lowercase I in invisible. So all instances of invisible with both uppercase I and lowercase I are going to be converted into supervisible. The line as it is will do this conversion only for the first match in each line. If you have several instances of invisible in a line, then only one of them is going to be converted. To convert all of them, you have to add G here. Okay, so we're doing this, we're processing the original file, and then we're going to redirect this output into supervisible.txt. Now let's see what happened to the now visible man. Let's do grab on supervisible in the new file, and let's count those matches. We have 173 matches, which is lower than this number. So what are we missing? Well, let's do the case insensitive search. We are actually missing all uppercase instances of invisible. So there are 3 of them, and now the total number is 176. Now let's remove punctuation from the original file using the translate command. I'm going to take everything inside the original file, and I will pipe it into the tr command. I will remove punctuation. So again, here we're going to use special syntax that is unique to the tr command. So we're doing this conversion, and then we are redirecting our output into the file. Let me call it a1.txt. It's going to be an intermediate file. Now let's take a look at the original file. The last 10 lines of the original file, there is punctuation. And now let's take a look at the last 10 lines of the new file. And there is no punctuation, as you can see. Now let's convert all uppercase to lowercase letters. We're going to take the last file, and again we pipe it into the tr command, And this time we are taking all uppercase letters and we are converting them to lowercase. And again, the result will redirect to a file. This time I'm going to call it a2.txt. Now let's take a look at the last 10 lines of this new file. And as you can see, everything is now lowercase. Now let's replace every space in the new file with a new line. So every space in the last file is going to replace with the end of line character or a new line character. Let's take the last file. And this time I'm going to use sed command. So remember, sed is really a great command for replacing text. So I'm going to search for space. And then again, this is really special syntax for sed. Every space is going to be converted into a new line. And we're doing this conversion multiple times per line. That's why we need the G flag at the very end. And then the result is going to go into file a3.txt. So this syntax is a shortcut for a new line inside sed syntax. Let's take a look at the new file. So now, as you can see, every space was replaced with end of line character. So that means that we end up with a lot of empty lines. In the next step, we're going to remove empty lines. This time, again, I'm going to use sed. This is a shorthand notation for an empty line, and then I'm going to delete these. So the last file is a3.txt, and now let's redirect all our results into a4.txt. Now a4.txt does not have any empty lines. Next, let's sort our list alphabetically. I'm taking everything inside of a4.txt and I'm piping that into the sort command. So basic alphabetical sort. And then the output of sort, I'm going to pipe into unique -c command. And unique command will only keep the unique instances of each word. And -c will also return the count per each word, how often that word is found inside the novel. And then we're going to take this list and save it inside the file a5.txt. Now inside of a5.txt, we have a list of words. These are sorted alphabetically, and then unique -c will make sure that each word is listed only once, and in front of this word we have is count. Next, let's sort the list into most frequent words. I'm going to say cat a5 into sort -gr, and these will sort numerically in reverse order by the value in the first column. So it's going to start from the largest number in the first column, the most frequent word, and then it will go down in frequency. So sort -g, and then the result I'm going to pipe into file a6.txt. Here we have a6.txt, and the result makes sense. The most common words in the English language are the articles, the, a, and we have and, followed by prepositions, and so on. And then we have finally the words that you see less frequently. Okay, so these are the commands starting from the very first conversion, starting from this one. Here we remove punctuation. Here we convert all uppercase letters to lowercase. Here we convert every space to a new line. Here we delete all empty lines. And here we take the list of words, we sort it alphabetically, and we keep only one instance of each word, and we also print the number of instances of each word. And finally, we take this list, sort it numerically by the value in the first column in reverse order, and finally, we get the output, which is the word frequency in the novel.